I would like, before we go into the discussion, to show you also some information on biofuels and electric alternatives, because hydrogen availability will be a topic to be solved within the next, let's say, decade, 2 decades, and we need some alternatives already now, or a mixture. I will keep it short for you, but I think it's an important topic. So biofuels, what do you mean? What do we mean with this? I mainly mean liquid or gas type biofuels. Biomass, it always depends a lot on where you get your biomass from. If you take trees and cut them down, that's CO2 that's long-term bound, and you put it back into the air, meaning you have a negative CO2 effect. If you have biomass, which is like waste that would be digested by bacteria very quickly, then this would put again CO2 or methane in the atmosphere. So in this case, it's CO2 neutral in the mid-range if you burn it or if you leave it to the bacteria to digest it. So in this case, it's a little bit more complicated. I will focus today absolutely and briefly only on liquid and gas type fuels. We have there, for example, bioethanol, methanol, plant oil, animal fat. We actually have projects with that, also close here to our factory, where they put dead animals you can't eat, and then there's lots of fat coming out of them, and either they pay a lot of money to get rid of this because it's a special disposal, or they use it and burn it and treat the exhaust gas so it comes out in a clean way. And that's the same also for a lot of fish factories, so as fish oil. And also we have biogas, of course, with the waste from agriculture, and sewer gas. And there, of course, it's recommended to take special burners. For example, for the liquid types, we need a burner with a centrifugal tumbler, meaning it rotates very quickly, distributes the fuel in a very fine way. So we have a very good combustion, but it doesn't get clogged up, because normally you would put it through nozzle that could clog up because you sometimes have particles inside. And that creates then inefficiencies, and also tends to, it must be serviced. You have to downtimes for your system. For the gases, most of them, they have lower heating values than natural gas. You have to, again, put more gas and air through the systems. And of course, you should use a combustion controlled technology. I'm almost through with it, just showing you how such a system could look like, because we design every boiler depending on the application. It's like, I don't know any boiler that has been produced twice here. In this case, it's in Denmark for the company Vattenfall. It's a huge energy company that produces electricity and district heat. And there they have a plant oil. And the topic is that it is clogging up the system because of the combustion that's natural with this fuel. They have to clean it, and they had to clean it up to 3 times per day, because they want to get the heat transfer surfaces clean again, because only if they are clean, they work efficiently. Otherwise, they use lots of fuel and have a high exhaust gas temperature. In this case, they use, as I said, a rotary atomizer, so a rotating cup burner. And here you see all these lines in the front of the boiler. There they have pressurized air and fully automatic cleaning, because you can't open the boiler, clean it 3 times per day, let it get cold, heat it up again, and so on. That creates inefficiencies. And here the efficiency is not as good as with natural gas, but still 93% is huge. If you compare it in the US, many boilers are running at like 84%, and they're proud of it. But it's always a question of how expensive your fuel is. And so this is a very good value, considering also it's without condensing technology, meaning exhaust gas temperatures roughly at 130 to 150 degrees. With condensing technologies, we achieve lowest temperatures coming from 1,700 degree of combustion down to let's say 58, 57, 59 degrees Celsius exhaust gas temperatures. So we are really using all the energy. Before I finish, let me show you a quick glance on electrical systems, because green power can also be used directly without transferring it to hydrogen, if I have it locally. And here we can implement electric coils inside the boiler, in this case up to 5 megawatts so far, probably later some bigger ones. And if it's green electricity, then of course this will be CO2 neutral. When do people do this? One reason is they have very cheap electricity prices, of course. They use it also for warm keeping, to not switch on and off the burner all the time. When they have excess electricity, because they have local electricity production and they don't get a lot of money when they put it back in the grid. And also for network stability. So sometimes they get some benefits from their power company if they consume in a continuous way. And then, of course, such a heating element can be an important factor to realize this, because the boiler is very flexible on which fuel he is using. Last but not least, of course, if you are producing electricity locally, it's rather a combustion engine or a turbine, and then you have exhaust gas from them. This is very hot, and you can still use this energy. There it's possible to use, for example, a full waste heat recovery boiler for exhaust gas. Also just use it partially here, introducing it in the fourth pass of this 3-pass boiler plus the fourth pass, or also using it instead of a burner. Of course, this is kind of CO2 neutral because the exhaust gas was already generated. You don't create additional CO2. And you can save lots of energy with it. Our typical applications are behind engines, behind gas turbines, also in glass work, so production of glass, steel mills, steel production, and cement factories. Finally, but I will keep this very short, optimization of existing boilers. If you look even in a high-tech country as Germany, 83% of all boilers are inefficient because they are very old, average age between 20 and 30 years. And there's lots of opportunities how to save energy there, be it on heat recovery, switching the fuel, also of course to hydrogen, by better controls, better optimization of the burner, saving electricity, water treatment, using condensate, and several other options. But that shouldn't be the topic here today. The coolest thing about this is it's quite cheap, it's known technology, and the return on invest on these topics is usually between 1 and 2 years, so much quicker than a complete renewal of a huge system. Last but not least, a curiosity. What I came across within the past years, that is, you burn a fuel, it comes out of the boiler as CO2, and then you reuse it in the processing. So I won't tell any names, but if you look at the right, for example, I know a very well-known beverage manufacturer that is available in all of your countries, where you have carbon dioxide, so the nice sparkle, that comes from cleaned boiler exhaust gas. It is cleaned, it's completely pure. That's the nice thing compared to also other options to produce it. And they put it back in the bottle, so they don't need an additional CO2 source, because they said, we already have a CO2 source, you just need to make it consumable. Also, for example, instead of the gas, when you have, for example, milk powder and the you have, instead of air, another gas inside, so it doesn't go into oxidation, then this is an option. And in colder countries, when you grow stuff in a greenhouse, they saw if they put additional CO2 in the air, that the plants are growing quicker with larger fruit, and therefore they introduced clean boiler gas into the greenhouses. They do this a lot in the Netherlands and also in Russia. So summing it up, finally, before we go into the discussion, already now, 20 to 30% increase of efficiency in many existing systems are possible. So I always encourage customers to look at that, even if it's not our main business, but just for the sake of environment. You can also prepare the systems there for different alternative fuels like biofuels, etc. Some few companies will have hydrogen available, and if they have, then of course it's an option to burn it and just get water instead of CO2. Or if you have it from green power, think about introducing electric systems, perhaps also as a combination. During the day, electric operation when the sun is shining, at night, use the hydrogen. Then you have a very much higher overall efficiency. So therefore, I see hydrogen as a major fuel in the long term of process heat and heating, and also the topic of synthetic fuels that are generated from hydrogen in order to make it easier to transport, to use, safer to handle. So in my opinion, my personal opinion, it will be an essential topic for the factory of the future, for the mobility of the future, and even in our personal lives, but this will be in the long term. The biggest effect for nature, CO2-wise, will be if we introduce technologies like these first for commercial and industrial applications, because the number of participants we have to reach in order to have a huge effect is much lower. Technology is available and also much more affordable. And in many countries, they also get subsidies for it because governments have their own CO2 targets and want to help companies to realize it. Therefore, my recommendation, check your existing systems. You will be surprised how much part of your CO2 footprint actually comes from process heat and heating. Check for subsidies. Perhaps you get innovative technology for free or subsidized. Check which fuels will be available in the future and make your systems ready for the future already now. Prepare for it. And of course, subsequently, if you have something available, introduce it because your kids will be thankful for it. I have one on the way at the moment as well myself. And so I'm thinking about what his, to be exact, her future will be. And I want for her to have a clean and safe planet. Yeah, therefore, this is also a really personally important matter to me. For Chile, we have also prepared a takeaway. And here, the recommendation is not just subsidies, but also look for pilot projects. Look if there are advantages for you, for your customers. Look, for example, for pilots in the mining sector or other examples with industrial boilers. Be part early, because if you are early in, you might be part of a huge industry of the future. And try to shape the norms. So if there are norms and you can work on them, they may secure your business of the future because they will be market entry barriers for your competitors later. Also, of course, transfer your knowledge, share your knowledge, and try to grasp knowledge from other sources, other countries. Look to Japan. They are very long already working on the topic of hydrogen. They are using it even in the personal sector already. And hydrogen is a competitive factor. If Chile or another Latin American country becomes a major supplier of hydrogen on the market, I think this is an important topic for the future compared to, for example, rare earth in the earth for mining or something that's somehow limited. Green hydrogen is unlimited. You need water, you need sun, and it's universally applicable. Therefore, in my opinion, technology of the future. We have our contacts here. Can, of course, take a screenshot, or, of course, look on LinkedIn. You will find us, Daniel Gosser. I think many of you are already following our channel.
Thank you very much, Felipe and Daniel. Excellent presentation, very detailed, good date, etc. Solo avisarles que la próxima charla no va a ser en 2 semanas más, sino que un poco movido por el tema que hay vacaciones en Europa. Así que, y la próxima charla va a estar la empresa Cummins con Hydrogenics presentando también cosas muy interesantes. Así que muchas gracias a todos. Thank a lot. Again, see you.
Have a great day. Bye-bye.